So what I have here is a particle demo. Particles, as you probably know, are when lots of little bits of things move around. I'm interested in them from for technical reasons. Using a particle system or similar, it's possible to render lots and lots of moving pieces all at once. And this is potentially relevant to the Run series, because, well, mostly because of crumbling tiles. Those have always been the laggiest part of Run 3, and I'm hoping that I can rework them to be less laggy. You may be wondering, I guess this is currently running at full speed. If my computer ever chugs, it's more likely to be because I'm broadcasting this than because of the rendering. The rendering does pretty good. But yeah, normally you don't use particles for anything you can interact with. There are particle effects in games and they just sort of happen, but you don't collide with them. Like you could walk through them, or like maybe they trail off a projectile and the trail doesn't matter, but the projectile does. That's how it works normally, but I don't think there's anything stopping them from being like larger objects that individually take up space. But we're not doing that today. Right now, we're just trying to get a sense of how Way3D's particles work, and whether they are in fact the right choice for this problem. And I want to start by looking at just how they animate in general. What we have here is a lot of things going on at once. The particle demo is complicated to show off a bunch of features, I guess. And I think the first thing I want to do is simplify it, break it down into its component pieces, so that we can get a better sense of what's going on here. I've already started taking a look at it, but then I realized I gotta start streaming before it's too late for everybody. Before everybody goes to bed. So I'm only partway through doing any of this. One thing I have figured out is that time behaves weirdly, in that they have a complicated formula for it. Hang on, I think I can up the font size. And if I up the font size a bit, you can get a better look at this whole function. This whole function does something complicated, but the fact that it uses a sign means that if we scroll up, here I am tracking what the time values actually are, and it's interesting. It counts down, it counts down very slowly. It reaches 0, and then it counts up, whoops. Okay, let's go back a full cycle. It peaks at 1999 and then drops... yeah, it varies between 0 and 1999. And I don't know why they chose those numbers, but I do know why that it's the sine function that does that. Oh, well, okay, I see. I guess I see how they got those numbers. Sine normally gives you values between -1 and 1. Add 1 to that, and it's values between 0 and 2. Values between 0 and 2 multiplied by 1,000 get you values between 0 and 2,000, which is, in fact, what we saw. It counts up to 2,000, spends very slowly when it gets near it, which is what the sine function does. I guess it peaks at 1999 because it rounds down. And then it drops, keeps dropping, and it slows down again as it gets close to 0, and the bottom is at 0. And so I guess I know how they got those numbers, I just don't know why. Also this part. I think my next step is to... Actually, we're not going to delete this. We're going to just minimize it. Divide it by a much larger number, because when we divide it by that much... what this does, I can tell you right now what this does and why. This part of the formula, math.pi, doesn't matter that much. Well, it did. What they want is to have two sets of animations, blue and white. No, they want to have 2 copies of the blue particles and 2 copies of the white particles. They want to have some number of copies. But they want to play multiple animations out of sync with one another. So while one of them... so somehow these numbers between 0 and 2,000 represent the timeline. Let me see if I can pull up information about the update function. Maybe not. But okay, they describe what's going on as updating playhead positions. So a playhead, like on a YouTube video, that's the red circle you can scrub back and forth. Well, we don't have a red circle rendered or anything, but these numbers going from 0 to 1999, that's the playhead. So like each set of particles has just sort of a preset animation timeline. And what this function is doing is it is scrubbing back and forth across the timeline. It clicks and drags. Yeah, I'll use this. So let's say over here is 0. It starts there, and it slowly builds up and moves faster through the... and slows down at the end of it. And then it clicks and drags the playhead backwards. Oops. Until it gets back to 0, and then clicks and drags it forwards again. And so it's like playing a 3D video moving backwards and forwards. So I think that's one thing about particles is you define a video, kind of. And then you can control where in the video it is. And I mean, this could be pretty useful for Run, in terms of... The trick will be, like if you're stepping on a crumbling tile and it falls away, that could be like a video. Except I want one that applies to all of them at once, which is not impossible. The moment you step on it, I can work ahead and calculate when every piece that's connected will fall, how soon it will fall, and I can make one of these videos at that point and then just sort of play it. I guess there is a question of we'll need to search through this code for when all of that is defined, but right now I made a change. Because apparently what's going on is it has multiple of these videos playing like overlapped on top of one another, and I want them to run at almost exactly the same time. Just to simplify it. Okay, so starting out, we see that everything is oh, wow. Okay, these are slower videos than I thought. Okay, so this is 3 videos. But, yeah, I might as well have deleted that whole thing. They are almost exactly in sync. And they're gone again. So apparently, no wonder. The reason you don't see that there are 3 videos is because for like a third of the time, they're just invisible. Sorry, 4 videos. And one of them is always constantly invisible. Or so sparse that you can barely see it. Now that they're in sync, do a better job of telling that. But they must have been trying to... Well, I don't know what they were trying to do, but if you remember earlier, there was a point in the cycle where they got spread out, so maybe they don't have quite enough videos going on to always have one in view. I don't know if that was the intent or what. In any case, yeah, they have something a little fancy going on that these 2 images, and you know what, I'm going to... the Hacks logo and the OpenFL logo. Someone asked about what programs are being used. These are 2 of them. Hacks is a language, so this code is written in Hacks. It's a coding language. OpenFL is a system for rendering, doing cross-platform. It provides tools to work in Hacks, and a logo that I don't have loaded up here. Okay, and I'm not about to. Away 3D is a 3D rendering system, for which what I'm running here is a demo of how to, do particles in Away 3D. So there is, I guess I'm going to scroll up a little, somewhere around I thought it was somewhere in here. Now somewhere it loads up the images. Oh hey, hacks.png. That's this one. It loads up this very image, and create blue and white point vectors for the Hacks image. So it takes those and oh man, it just looks at every single pixel, and if it is if it's blue-ish, if it has any blue in the pixel at all, which, I don't know, I guess there are RGB pixels. The visible pixels, I think, show up as blue, and the non-visible pixels show up as white. I think that's the idea. Yeah. Glad you're enjoying the game, and I'm hoping to get other stuff out so that you can play it. But first, I do want to at least try revamping the crumbling tiles and all, which is what I'm doing here. Oh man, it does. Yeah, it does once for OpenFL.png, once for hacks.png, and we end up with these things called white points and blue points. Which is just, it converted the bitmaps into a different format. What does it do with this? This data later shows up. I'm sorry. Pressing the escape button should not close the window. I will have to look for that later. But no, seriously, I pressed this to escape and it just closed. It is good that it remembers everything, but it's still a bit of nonsense. Okay, so yeah, what I will need to know is what we have here is init particles. This is the function that's supposed to initialize all the particles. Okay, it takes information about bitmaps and it creates animation sets, which I don't know a whole lot about, used by particle-based animators containing particle animation data. I want to go look at where it's defined for a moment. Yeah. I know this is a technical stream, and I'm a little sorry about that, but this is what I've been doing lately. I've been working on code and stuff. I'm hoping at some point in the future to have better, more easily understandable code. But right now, when I'm figuring out someone else's code, it's just a bunch of looking at arcane text that won't make sense to all that many people. But I still figured it was better than skipping a stream day, you know? Particle animation nodes. Okay, so I want to know what they mean by nodes. Wow, that's... node priority. Wow, this is... Okay, so let's look at a concrete example. A particle animation node. I'm trying to figure out what they mean by the word node. Tunnel selection question. You've been curious about that lately. Quick answer, there's a list of levels that's supposed to go from easiest to hardest. And I don't know, let's get some numbers 1 through 9. Say there were 9 levels. There's a difficulty value that starts around 1, or maybe it starts around 2, but your current difficulty starts low and goes higher and higher. But there's also, you don't always get the one that's exactly at your difficulty, because then infinite mode would be the same every time. Instead, it's difficulty plus or minus 3 or so, except it's that's not a hard limit. It's a sort of standard deviation thing. So actually, I think it starts out, well, in this example, it would start out plus or minus 1. So odds are 1 standard deviation is 1. 2 standard, like 1 standard deviation could get you from your difficulty of 2 down to 1 or up to 3. Sometimes there are 2 standard deviations, that's rarer. 3 standard deviations can happen, but it's even rarer. Beyond that, like, theoretically possible, but ignore the possibility. Like, look up standard deviations for how that works. As time goes on, you end up with a difficulty. I don't think the difficulty can ever quite max out, but it can come close. But the standard deviation is also higher. It's at least 2 by now, so you're pretty likely to get a difficulty of 6 even when you're maxed out. And for details, look up standard deviation and normal distribution. I'm here to explain coding stuff, and I'm happy to take breaks and spice it up rather than just particles. But I was trying to figure out what this means. Particle billboard node is a thing that is used here. So it's added to white particles, it's added to blue particles, and the purpose is apparently to make the particle always face the camera. So I'm wondering, if it was not added to particles, could you see that they weren't facing the camera all the time? And I actually tried this off stream and I couldn't see it, but I don't know, maybe someone else has sharper eyes. I don't know if the stream quality is actually good enough. We're going to have to wait for them to appear. Oh, I did also implement a way to slow down the animation. So I'm going to do that. And I'm looking at, like, the square particles up here. Oh, I can see some of them spinning. Yeah, okay, so they're not always facing the camera now. Okay, that makes sense, I guess. Yeah, so I was thinking, well, if you just want a little square that's always facing the camera, isn't there a better way to render it that just guarantees it's always, but, maybe not. Maybe it literally just renders 3D squares the entire time, and does extra processing to make them face the camera, and it's still fine because particles are fast. I'm not sure. And here's the code. It is really inconvenient to read this stuff, even for me, who's who kind of knows what even to look for. The code here is... I've written shader programs like this. I know how to do it. It's not fun, and it's not fun to go back and figure out what it looks like, or what I meant when I wrote it. M33, matrix multiplication. So this whole thing that I've got selected is a single line of shader code. In fact, it is a single instruction to use a matrix multiplication. Matrix multiplication is pretty cool and can be done more conveniently on the computer, on the CPU side of things, using a matrix 3D class. 3D matrix contains information about positioning, moving from, like, move 10 units downwards and 5 units sideways. Rotation, spin 30 degrees left. Scale, scale it up a few times, a little bit until it's visible. Whatever. And it's relatively easy to combine matrices. So you got one of them to define where a tile is in space and another of them to define where the camera is in space, and if you combine those, it'll tell you where the tile is on screen. Like, it takes the camera into account, it takes the tile into the account. Is it going to be visible? And if so, where is it? Is it going to be at the bottom corner of the screen, top corner? Whatever. It'll figure that all out just by multiplying a couple values together. It's pretty clever math-wise, and really important for 3D rendering, which is why they have a matrix function. So I think M33 stands for matrix 3 by 3. And okay, so yeah, so it's a it says take this amount, multiply it by this matrix, and store it here, which is the same place. Okay. So it's doing some it's just doing some matrix multiplication, which, yeah, the thing about this is, not only did they make a language that's really hard to read in general, you have to kind of build it based on other stuff, based on variables, and the matrix itself is stored elsewhere, so who knows what the matrix does. It can do almost anything in terms of moving stuff around. So I guess I'm not going to spend any more time trying to figure that out. I will trust them when they say it rotates the particle to always face the camera. The main thing is it does this I think it adds this code to a bigger set of code. And so if I look up this one, I go over here, there will be a similar thing. Yeah, same function, with lots more code. the description is partially a joke, but some people... I'm going to try not to require you to actually do the math in your head or on paper, whatever, like at all. But yeah, mostly this is going to be an obscure stream with me discussing, trying to explain stuff that's difficult to explain, more so than usual. Sheesh, velocity and value. I mean, I do like that some of these values are well named. But yeah, it's annoying that you have to type mul this, that, the other, rather than... so I think in regular code it would be this equal. Well, in regular code you would be able to use a multiplication symbol. We use an asterisk because it's conveniently available by pressing Shift 8 rather than the little bullet that you're technically supposed to use to represent multiplication. Didn't mean to start too much of an argument. I recognize that all kinds of professions require, are difficult. If they weren't difficult, they wouldn't make the money they do. If it was easy to become a best-selling author, everyone would do it. But yeah. So I'm thinking that this, not wanting to dig too much through this, somewhere in here is the code for a Bezier curve. The same curves that I used in an earlier stream to draw the angel. With this tool? This tool. Bezier curve. Start point, end point, control points. Oh. Vector layer. So, yeah, in this case, it's not for the purposes of drawing a line, but for movement. That every particle wants to follow a curved path, and Bezier curves are very good at being able to define arbitrary paths. So, you probably have 4 values here. Start point, end point, starting control point. I'm going to move them. Start point is the one I'm moving here. End point. I'm going to put it over here. Start control point and end control point. And then I also time. That they have a time variable, and the particle is supposed to get from point A to point B in x units of time, and then it calculates from that. If the current time is x over half of x, then the particle will be halfway along, somewhere around here. At 0, the particle's here. At 1, it's here. At 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then it ends up there. And so this is probably the sort of timeline thing I was mentioning earlier is just a bunch of Bezier curves. And if I can go over here, well, it only adds one node, so it's not the node. It's so it defines a few values here. It defines a I guess this is the start point, and this is the end point. This is the end point. And then there is a very complicated control point. I'm sorry, there's only one? It's really weird. Like, you can do curves that have only like one control point. I don't know if it's mathematically equivalent to a 2-point curve where both points are at the same spot. It is very limiting, though, if you only have one control point. So that's a little confusing. Like, if I always move these to the same point, I can make various different curves, but not a lot of them. They're always this sort of same shape. I can't... there's no way to do this. There's no way to do a more smooth thing. It's always sort of pointed. So I don't know what's up with that. Reference for representing the control point position of the curve. It's a curve with a single control point, so it must be this. Okay. You are probably not the only one not to understand. I am currently having difficulty understanding, but I'm trying not to jump topics. I'm just explaining the topic in different programs. Currently, I am trying to figure out how they do everything in the animation I showed earlier, and apparently they do use Bezier curves somehow. I have not yet finished figuring out how. But the point of a Bezier curve is that you can define a start and end point and apparently one control point, so these are like at the same point, and then have a particle follow this path over time. And that with enough of that going on, you end up with the particles following a more complex path. Let's fast forward a bit until they show up. Yeah, they're all moving into place and then around. And each particle must have its own curve that it follows. But I am still confused about how it all works, because I could have sworn that it would be more than one curve. Like, I could have sworn that you would have to... Like, you would have to have a couple curves joined together. One curve here. One curve here. so that the particle can go there and maybe, loop around, because they seem to be looping around, I don't know, did they do a full circle? But to get a good loop like this, especially with, the main thing is that, how they reach they join together to create an image. They do that because they have a predetermined route. Like, each particle has a predetermined route that ends in this image. Yeah. It ends up exactly where it's supposed to be. And then it moves on. And then the blue ones instantly disappear, which is weird. I think that's a bug. Or maybe not. Yeah, no, apparently the blue ones just don't appear for a certain part of the animation. It's another weird thing, but... yeah, they're moving, following Bezier curves. That part is obvious. I'm just trying to figure out how many Bezier curves they use, because they ought to have to use more than one to define motion that complicated. And there's a degree of randomness. Okay. I'm not too worried about the actual math behind Bezier curves. I'm sure that part's fine. Right now, I just... so I'm looking at this code. I don't want to get into too much detail about the code structure. The main problem I'm having now is that this code seems to define a single Bezier curve, which is like that. One start point, one end point, one curve. Which is great for doing part of the animation. The particle follows a curve and ends up... I'm going to... yeah, we're going to do that. This particle is supposed to... it's supposed to be one point on, this image. There we are. It's going to be... it's supposed to land at the top corner. And so we calculate where it's supposed to land, and we record that point, and we calculate where it's supposed to start, and we record that point, and we play the animation, and this particle reaches the correct point at the correct time, and that's great. And 1,000 other particles do the same thing. Another one lands there, another one lands there. They're all coming from different spots. Another one there. And that's great, and they all move at the same speed and arrive at the same time. And so you get this big animation where everything all slowly comes together, and arrives in place exactly in place at the same time and allows you to see the image that they're based on. Now, they're perfectly in place, and then they move on. But they don't go back to where they originally were. They go off and do something else. I think make the... and so that's the part I'm confused about, is they're not just doing this and then bouncing back and returning to their original spot. That's a thing they could do. Instead, they are just sort of passing through. So they arrive at this point, and they go off and become a confused mess over here, and then they turn around and they come back, and they pass through the image again, and they make the image again, and then they go and spread out and go all... everything goes all dark for a bit. I think that's how this animation works. It starts out all spread out, and all the particles come together, and they make an image. I kind of get how that works. They've got a pre-charted route that ends up with all of them in the right place at the right time. And then they make that image again. And then again and spread... Okay, so it's... I should not close that every time. There are actually 2 predetermined images. And each particle has 2 destinations, somehow. So the particle sort of has longer lifespan. Each particle has one track that it follows throughout the entire animation. It starts out spread out. It comes in and forms an image over here at time 1. And then at the end of the animation, it forms an image over here. But as I said, or as I partially described earlier this stream, the animation doesn't just loop. It plays forwards and then it plays backwards. And so at this point, this second image is the midpoint of the animation. And so it forms an image over here, and then it comes back and forms an image over here. Or who knows, maybe it's the same animation and it's flipped around. But that seems even more confusing. I want to figure this out because I want to make my own animations with my own custom paths. I want crumbling tiles that fall in specific patterns with specific timing. I don't necessarily need a curve, but it is... If you have a Bezier curve, it is very easy to create a straight line. That's not a problem. And I also... I want to figure these particles out because with particles, if they load quickly and render quickly, I could add other cool effects to the game. I mean, I guess I just must be wrong about something here. Because as far as I can tell, they really did only define a single curve. Okay. Okay, so I'm just trying to figure out what all of this does. So this if else. Okay, all of this code is run once per particle. So each particle gets a position, a Bezier control, and a Bezier end, but it only gets one of these, one endpoint, because that's what if else means. Don't worry too much about it. I have gone through and figured out that this is just separating the one image from the other, this image from this one. So, okay, among the many things they do backwards, apparently this is the start point, this is the end point, and they just start at the end point and go to the start. I don't know. Yeah, so their start point is the point in the image. This is not quite well enough named, but they set the start point based on the image. And then they set a Bezier curve, a single Bezier curve, out to another point. Actually, it looks like absolutely everything starts at the exact same point. Except, well, no. Everything for one image starts at one point, everything for another image starts at another. So we are going to clear out that. We have two images. And everything for the Hacks image starts over there and moves in and makes a thing. And everything for the OpenFL image starts over here and moves in and makes that. And so the Hacks image, I'm just going to draw two particles because these lines are so long. Actually, I'm tool options line. Thinner lines so you can see. And so these are just a few particles, but these two particles started at the same point, and they ran over to form 2 points in the Hacks image. And these particles started at the same point and ran over to form 2 points in the OpenFL image. And multiply that by a couple thousand, and you get this. Tons and tons of particles slowly moving in. That start takes a while, and form an image. Boom. Oh! No. I'm not sure I figured it out. I'm going to do a top-down view for a bit, just watch another full cycle of it. Yeah, I mean, you can see that they start way out in the middle of nowhere. You know what? I need to make there be fewer copies of the animation. So there we are. Right up here, we're going to do a single animation. And so there are going to be fewer particles, but they will show up. So my thought is that this is the midpoint of the animation, somehow. Yeah, it slows to a stop there and turns around, which is exactly what we expect the timeline to do. So I am curious. It looks like the images switch sides. Let's hurry through this and watch it again. So Hack's over here, and it looks like they're swapping sides. And then Hack's is going to be on the left instead. Yeah, and this is the midpoint, and then the animation turns around and just goes backwards through everything they do. So they swap sides again. And Hax is over here, and then this is back to the start of the animation where everything is invisible. I don't know, can I leave this visible on one side and run over here? Look at code over here. So I do need to figure out what the difference is between all of these, and is it literally just the particle count? Because there is something else different about the functions that I haven't figured out, which is why do blue particles never appear? Man, I was hoping to be writing my own code by now, but this is more complicated than I thought. Oh, missed a comment from earlier. Interest asked if the other cool effects would make it laggier. The idea is that particles are fast, and it's possible to do, using particles or other means, but ideally particles, it's possible to do fancy effects quickly. And this is just one way of doing it that I would hopefully, like, once I figure out how to do, I would hopefully be able to use for several purposes. Yeah, okay. They have separate functions only because there are separate numbers of the particles. Okay, I may need to look elsewhere. Okay, just wondering. Okay, so I do want to see what happens when I mess with that variable. It looks like a radius variable. They didn't name it very well, they just called it r. But my thought is that this makes them spread out a little less when they're not currently busy making an image. Yeah. So I only changed it for the blue ones, so the blue ones don't spread out as much. Okay, so that scatter is entirely... Oh. No, we're going to find out more of this by making the radius almost... like, I could have made it 0. It's basically 0 at this point. So what happens when we minimize spread? It looks like they still make the image the same number of times. 1... Okay, yeah, when, without this random spread, the images just sort of slide past each other, and then... The blue particles disappear, so I don't actually know what's going on. Oh. Okay, so without this randomness... Ooh, this... Yeah, this is actually very useful. Oh! Oh, I get it. They are always sort of in the shape of the image. Okay, I need to update my diagram because I'm a lot closer to figuring out what is going on here. This particle, well, currently with them sliding sideways, you just have a bunch of particles that start out. They start out in the shape of the Hax image. And something like that. They end up in the shape of the Hax image. They're always... Oh no, did those get merged? They did, okay. Wow, what? Why? Seriously. Okay, welcome back. I have figured out a thing or two. There. I want to make a copy and over here and also lines. So what's currently going on now, if I were to put this over here, you would be able to see two images just sort of sliding past one another. And this is because I removed some randomness. And so I'm trying to... Why did that go over there? I need to move a few more things, but we're going to put these here and make them blue. Different blue. We're going to make these orange. Even though the particle system doesn't use blue and orange. So each of these lines represents a single particle, and there are just lots and lots of particles. So there are a lot more lines than this in theory, but basically we're going to move it there. What I'm trying to convey is that you have particles starting out way on the edges over here. And they slide this way. And they're always in sync. And they end up over here. But actually in the middle... Actually, no, I need to show the motion. Okay. Watch this. So the Hax particles start out over here. And they each follow their line, causing the image to move here and then there. And at the same time, I can't move these images at the same time. The OpenFL particles start here. And so here are lines showing one of them at the bottom of the L and one of them at the top of the circle. And each particle follows these lines. And with no randomness, you can just see them do it. They keep the image the entire time. And they slide past one another, and they come to rest, and then the animation turns around. As I've been saying, that's the halfway point, and then they go past each other, and the blue ones turn off for whatever reason, but they go out to their starting points way out there. And then it turns around again, and rinse repeat. So there, back, there, back. That's the entire animation. Except there's randomness, and the randomness, it turns out there is only one Bezier curve each. But the randomness is in this control point, and each particle has predictable start point, it has predictable end point. It has an unpredictable control point. And a control point that starts at the same spot, ends at the same spot. But who knows how it gets there. And so this is... so with that randomness, the Hax image is going to start out over here, and it's going to explode into 1,000 pieces. One of which follows here and ends up there. The other which falls there and ends up there. Kind of. The part that's missing is that each of them also has to guaranteed form an image in the middle, and I don't know why that's guaranteed. So what happens here is, again, logo starts out over here, explodes into 1,000 pieces. They join up here. And then they keep sliding sideways and join up there. And if I add a little more randomness back in, this may become a little more obvious. Okay, so out there... Oh no, they're spread out there too. They're coming in. They form an image right there, and then they keep sliding. They spread out a little bit, and then they come back together to form a perfect image, and then they spread out a little bit. Again, I've only added a little randomness so you can see what they're actually doing. I should really... I'm going to make the blue ones even more random. So the white ones are less random, the blue ones are more random, and try and make this more visible. So their starting position is kind of random. Which is weird. I mean, it's not too surprising that they're sliding sideways. They've got their end point is just in a single direction. Single straight line out in one direction or another. Okay, so I am a little curious. Okay. Plus. Yeah. Okay, yeah. So I figured out where they define the points they move between it. Yeah, the main thing I'm confused about is how do they guarantee that they make an image right here. And also, why did the blue points disappear? I'm going to work on that for a bit. So those all look the same. Is it in the timing? I'm going to go down to where the timing is done. Okay, I'm going to look at the blue particles. No? Going to look at the time. Nope. It's somewhere in the animation. Start time, duration. Well, I'm going to mess around with stuff until I start understanding it again. In this case, I want to skip some of the startup. Well, I kind of did. Yeah, so I only changed the timing on the white particles. And it looks like they are a little broken now. Oh. Oh, it's not what I was trying on for, but I may have just figured out. I bet this is supposed to be symmetrical. That it is a Bezier curve with 2 control points, like what I've been messing with in Krita. But you only define one, and then the other one is equal and opposite. So, it always reforms the image halfway between the start point and the end point. Just on account of if this one's here, this one's here. If this one's over here, this one has to be over here. And no matter how it goes, these orange lines are 2 separate paths for 2 separate particles. But as long as let me something like that, yeah. As long as... Oh, actually, I can have them both visible at once, and then I can make them equal. This one and this one... Aha. They're about equal. So... what I'm saying is I think this one is always equal to this one, except opposite. And likewise with these... equal and opposite. And what that means is that these 2 separate particles and thousands of others will go their separate ways when they're not at the end point, and it will create this explosion effect. But in the middle, they will always be a set distance apart, no matter maybe I should make a third just to drive the point home. That I'm going to do this, and this one is okay. Let's go extreme. This one is straight down. And the ending is straight up. And it should be orange as well. Recent. And it should be it. And what this guarantees is that these 3 points, which represent different corners of this, plus all the other points, they're guaranteed to show up at the correct point on the image over here, and at the correct point on the image over here. But also, at some point in the middle, they're guaranteed to meet back up. And if I get these exactly the same, you can see that they all roughly pass through. Man, it's hard to see. They all roughly pass through the somewhere around here. Like, there is a point in the middle where they all end up passing through their correct point on the image. Man, that's weird and complicated, but I think the math works out. Yeah, did warn you there'd be math. That the mathematical property we're thinking about here is that point A, point B, that the midpoint of this, I'm gonna show it, that if you define the endpoints in the correct way and they are okay, actually, a simpler way to define it, a symmetrical Bezier curve is symmetrical, and the halfway point will be halfway. That if you do a symmetrical thing, it will always pass through the halfway point. I'm just going to mark the halfway point. That point is pretty much exactly halfway between these two endpoints. And as long as I keep these symmetrical, it always passes through the halfway point. Yeah. Same length, same direction. And there's probably a mathematical proof. Well, yeah, it's all about the halfway point, it turns out. That the image forms 3 times. It forms at the end point, it forms at the halfway point, and it forms at the start point. And you don't need a lot of data to find that, just the start point, the end point, and one of these, and make the other one symmetrical. And then everything is guaranteed to meet back up at the halfway point. I know this is not the most exciting thing for me to have figured out, but I'm happy to know it. Man, this takes a while. It feels like it's not a halfway point, though. That, like, halfway all the way. All the way. It also feels like the distance is not halfway. Or does it go? Yeah. There's still a lot I don't know. But yeah, I might stop trying to figure this all out and get into making something. Yeah, I want to, just as an analogy to crumbling tiles, I want to make an animation of, gonna still use this image because that part's in place. But we're gonna have it just sort of crumble away in a random direction. So we're going to do straight lines for now. And we're going to randomize the direction. and it's also going to play backwards. I haven't figured out how to start in the middle. And the blues are just going to behave as normal. Yeah, so these don't meet back. These only form the image once, which is kind of the point. Okay, that's actually unnecessary. Okay, so we form the image, and then everything disperses in a random direction, I believe. Oh, let's speed it up, actually. Yeah, that's pretty random. But what if it wasn't totally random, but sort of directed? So it starts when it's still actually going outwards. Two opposite directions. Should maybe make them go the same direction. Yeah, I'm going to make them go the same direction. And we're going to give them a bit of a curve, but we're all going to give them all the same. They don't seem to be spreading out as much vertically, and why is that? I copy-pasted this formula, and I don't really know why. Without any randomness, but with the curve in that direction. Finally move sideways, and then come back. Wait, do they need to move sideways? Oh, that was a silly test. I was trying to test if I could make them move the other way sideways, but I don't actually know which way is the other way. So I'm going to try that again. I'm going to send them in different directions. Interesting. Okay, I'm kind of wrong about the symmetry thing. All this sideways movement is entirely due to the control point, somehow. That's not symmetrical. I don't know what to make of that, which probably isn't a good sign for my stream being understandable to anyone else at all. But I think that's already been well established. This is the programming experience. You stare at something not knowing what to make of it for a long time, and eventually you figure out how it works and what you're supposed to do with it. Cool patterns there. I'm going to try bringing back a lot of what the original thing was. Well, okay, I mostly just got rid of the randomness. I guess I'll add randomness. But only in one axis. So smears out. Huh. Why can I not get that effect unless I use randomness? Like the effect where it is visible for a moment partway through the animation. Well, maybe because the... Like, does the image stay visible for that same amount of time? Well, okay, yes, the image stays visible permanently. This is an interesting path to follow. Okay, I'm starting to approach a new hypothesis. Never... Well, okay, I'm not quite sure what to make of that. Huh, you only set the control point and the end point. Well, yeah, this is not entirely documented enough. Like, I got that the point is to move the particle along a Bezier curve, but it's not acting like I expected to. I set an endpoint. Everything should end in the very center, and it's not even touching that. Look at this. 0, 0, 0. That's the center. And not even a single particle reaches the center, much less all of them at once. And a lot of that seems to be due to the curve, the control point. Okay, so this is what happens when the endpoint is 0 and the control point is 0. No movement. All movement you see is just the camera. And I've currently fixed the camera, so nothing moves at all. Neat. That's... well... that means that an endpoint of 0, 0, 0 actually means that the endpoint is 0 units away from the start point. We're going to set an endpoint for, I think, the hacks one, of some units away along just one axis. No, it's the OpenFL one that's moving. Okay, we set an endpoint for that, and it's directed, it's relative to the start point. And now we'll do that. Just going to move the OpenFL logo around in different directions. Okay, up and down. But it's a distance. I'm not setting a final, like, exact point in space. I'm setting a relative point. Okay. And now we're going to set a control point. Still up and down. Or down and up. Down. So it goes up a bit, it comes back down and goes way past. Okay. Yeah, I think I get it now. It goes past because the time goes out of bounds, I guess. Forget. Okay, I need to actually look at the time values. We're going to display those again. Okay, so when time is 0, start there, then time goes past 1,000. Okay, so we're going to time can no longer go above 1,000. It will just sit at 1,000 for like half the animation. So these will sit still for a while and they will move while time is under 1,000. Huh. Well, instead of that, why don't we just do the full animation? I should really be displaying time. Okay, that's pretty good. So okay, yeah. Well, I don't know if anybody else will keep up with this, but will update this. It's not a halfway point at all. It's not symmetrical. It's not anything. It is this sort of very simple Bezier curve that does not give you complete control. And the only thing we're doing is we're kind of extending it. Particle starts out over here and ends up back where, well, no, ends up at the end point, goes from the start point to the end point. Took me a bit to figure out how to find that, but then it goes past the end point, just sort of in the same general direction. And that means that it does not form the final image out here. It just kind of scatters off into the distance. What if I delete the stuff I'm not using? Particles start out in the same spot on the image. They reach the same spot on the image, and then they leave. And they end up way far apart. So start out in a certain distance away from each other. This is supposed to be their end point, is on the same image, just in a different spot. And then they scatter. And the direction they scatter in is determined by the direction they were already going, so follows this path up, down, down, further down, and they scatter down. This one was going down, up, further up, and it scatters upwards. So, yeah, you can usually take a math function that, if a math function creates a smooth curve and has endpoints, you can usually just keep going beyond the endpoints and it will continue smoothly. So that's kind of what happened here. The start point is there, and it goes up and it comes down and it returns to the start point and keeps going and going and going and comes back. Okay. And this is currently let's add a few more pieces back in. Let's look at different directions. These two images are now going in different directions. They reach a fixed point. This is the start of the animation. They go toward the control point, they come back, and then they go off into the distance. but they met back up. And now we're going to split them up a little farther. Just, oh, I'm sorry. We're gonna want to split both images up a little farther. Hopefully doing this step by step will allow you to see. Come on, get over here. So now about half the particles are going one way and half the particles are going the other way, but they meet up. Start point, end point. Let's send a third of them off in a different direction. So now the image is spread out, but they always meet back up at like twice. Those 2 points are the start point and end point. And they just continue. You see that the direction they split off is like continuing their momentum from this section where they move a little distance and then they move a long distance, but continuing the momentum from when they moved a little distance. I guess to distinguish between the start and end point, we're just going to push them forward and back. So these are the start point and end point are forward and back. And so if you just look at their movement forward and back, you find that they smoothly move in that. Well, actually, no, that's a bad. Like, ignore that. That's not going to be easy to understand. I was hoping it would, but it won't. Yeah, instead I'm going to just split some more of them up in different directions. Yeah. And so no matter how many directions I split them up in, they always meet up. Like, they always have that information about where in the image they are. They go off in different directions, but they keep that information. And the more I split them up, the fuzzier the images get when they aren't meeting up. But you can see that they are following a preset curve that passes through, like, makes the same image twice. And that is still what's going on when randomization is happening. But the main difference is that when it's truly random, there are so many different like image pieces that it's actually like every single one of them is on their own curve. So only when they meet back up do you get a perfect image, which happens twice. But it's as if I kept splitting off more and more particles. Like you saw me split off a few particles and then like half the particles and then another third of the particles, if I kept splitting them off more and more and more, you would end up with this. Which is to say, they're all going their own separate ways, but predictably. And yeah, the main trick is that it's... I'm going to go back and deal with that again. Main trick is that they go beyond the endpoint. Like, there's a point that's called the endpoint, and it doesn't stop there. And if I edit the time function so that it does stop at the endpoint, then you'll be able to see that the start and end of the animation are just when it forms the image. So start of the animation, end of the animation, start of the animation, like start point, end point, start point. And so that's why it comes into focus twice, because it's in focus at the start point, it's in focus at the end point. And they just did a little mathematical trickery to continue this momentum. In the direction that let each particle follow its own path well beyond one of these 2 points. Which is neat. And that, and add the blue particles back. And we should be back to the original... Oh no, wait, the time is... I still modified the time. Okay, so yeah, these are the start points and end points, and it's just that they actually want that they want it to go beyond one of those. And there's something about the blue particles that don't like going beyond, but the white particles don't mind. So if the blue particles never need to go beyond, they will do... Oh. Okay, I wrote the code wrong. This should hopefully create a smooth animation where the blue particles are always visible. Yeah, and of course they are still stuck with predetermined path. Okay, I'm going to I still don't know what's up with the blue particles not liking going beyond. Done that. Okay. Trying to find something in the code that is different between blue and white that makes blue not work but white work. Geometry. Is it the material? Man, I wish I looked at that before. I could have made the white particles so much easier to see. Anything special going on? I don't see it. Man, I know it's a small thing, but it always bugs me when something is doing well, a lot of stuff bugs me, and that might be obvious from the stream so far, but I feel like there ought to be no difference between the blue and white particles, and yet there is. I just don't see any code that is significantly different. There, no code that would cause this difference. And yet it is always different, always. I made the white particles brighter as well. They use the same classes, the same initialization, and same nodes. Like there might have been something about the Bezier curve that one calculation didn't like it, and one didn't mind it. Yeah, none of this is it. I'm about done here, but I need to figure it out. Ideally, I'd like to explain it to you, even if no one really cares. But yeah, none of this even distinguishes between the two things. They have the same rotation. Use the same thing. I copy-pasted this code, it's all the same. Except for... Oh! I found it. Uses duration. Oh. Okay, that was it. Okay. I found the little bit of code that was different. And now we have this animation. The blue is visible the entire time, which I really do like better. So one last thing to look at before we go is turning everything back on with the slight changes that I've made. Mostly to make it more visible, and you can see it's now it's a little more possible to keep track of everything, and you can see that, well, if you could follow any of the concepts before, you can probably follow this. If not, I guess just keep your eye on one mass of it and watch as it comes in, crosses over, stops. This is the start point. This is the end point, and it goes beyond the end point and explodes out into this mass way out there, and comes back to the end point. Yeah, so the last thing I changed, besides bringing back all 8 of these things, was there was an instruction that beyond a certain point, don't show the blue particles, and that's why they would disappear. Oh, actually, I do want to change one more thing. I want to offset these animations again, which is which now means that there'll be, okay, so yeah, I know it's complicated. Sorry, ideally I could have explained it perfectly for everybody to understand, but may have not been meant to be. short answer, what happened during the last 2 hours is I took apart this animation to figure out how it works. And I determined that, yes, every single particle you see here is moving on what is essentially a single line, though it's more like a line with a couple extra parts, kind of like this. Oh, well, that's not visible at all. Let's see if I can make some room. Kind of like this. Every single particle here has 2 points where it's supposed to be. Start point and end point. And when a lot of them meet up in their respective assigned points, you get an image. That's like an image is a bunch of pixels all next to each other, or in this case, a bunch of 3D squares all next to each other. And when they're arranged properly, you get the image, and you can see the image, and read the text and all. But each of them has its own curve that sends it out in a slightly different direction and makes the whole mass into a cloud, because they all go off in different directions and aren't lining up except at 2 very specific points. It's a preset curve, so like it kind of looks like a random cloud, but the cloud is the same the entire time because it's all predetermined. Until I refresh the animation, in which case it's re-randomized. But, other than that, like as long as I keep this going, the animations are exactly the same every time. Which is neat. Usable. As with pretty much all streams, I was hoping to get more done, but, unexpected setbacks. In this case, my unexpected setback of the day was that it was harder to figure out what was going on than expected, mostly because of the tricky thing with time going past the supposed time limit, which causes it to go out there and explode. But I eventually figured it out and attempted to explain it. I guess the other thing we learned here is that this is just really complicated and really hard to explain. So, I wonder if I could do something else, some other stream, to explain it better. That's for another day. But to be honest, I probably don't need to explain this. I will instead be, next step is to try and use it in the game, and instead of explaining this, which is unnecessarily complicated, I will do something less complicated in-game and explain it better because it's less complicated and easier to follow. So I guess you can look forward to that. At some point in the future, I will be using these ideas, but in a way that you can hopefully actually understand. And with that, I will see you on Saturday.